explaining without recording, but yes, it is being recorded. All right. All right. Now they say for a equals to 1 over n. So now you have x to the power 1 over n. Remember, 1 over n means the nth root. All right. I'll mention again. X to the power 1 over n simply means n root. Therefore, for n equals to 2, we have square root. For n equals to 3, you have cube root. All right. And for n equals to 2, you have square root. The domain, what is the domain of a root function? I say everything under the root has to be greater than or equals to 0. That's why we get this domain there. All right. But be careful for a cubic. So for cube root, the domain is the entire set of real numbers. All right. So please don't get confused. If n is even, so you have n, you have square root, fourth root, or sixth root, eighth root, 10th root, and so on. The domain will be from 0 to infinity. If you have odd root, for example, cube root, fifth root, and so on, you get the domain to be the set of real numbers. All right, the whole set of real numbers. All right, this is just a sketch for the cubic function. And like I mentioned, for a cubic function or for a cube root, you say that the domain is a set of real numbers, all right, because it's an odd root, all right. Now let's look at power functions that are now reciprocal. So reciprocal is just x to the power minus 1, which is 1 over x, all right. Take note, if y equals to 1 over x, it means xy equals to 1. You get something called a hyperbola, all right. So you get something that looks like this. Hyperbola, it has two sides. Why doesn't it cut this y-axis at some point? You can see there, the bottom there, x cannot be 0, all right? If y equals to 1 over x cannot be 0, means that at the point 0, you're going to get a discontinuity, all right? Now let's discuss rational function. We're almost halfway gone. All right, rational function. So rational function, you can see there is a ratio between two polynomials, p of x, q over x. Again, for the domain, you make sure that q of x is not equal to 0. All right. So, for example, this is an example of a rational function. And what is the domain? The domain is x squared minus 4 not equal to 0, because we can't divide by 0. Therefore, we say x plus z, x cannot be equal to plus minus 2. All right. Now, let's look at algebraic function. Algebraic function is everything else. So we've seen all the other function, everything else that I haven't mentioned is called algebraic function, all right? You see it's a combination of root function, power function, rational function, root function. Once you start seeing these combinations, the first thing that comes to mind is algebraic function, all right? Here they say any rational function is automatically an algebraic function. So keep that in mind. So any rational function is an algebraic function. And exceptional cases, that will make it really clear there is an algebraic function where it does stuff like this. Cube root of x plus 1, and then times some linear function. Those combinations gives you a hint that this is an algebraic function. And take note, the sketch of these functions are not easy to get, so look at this one. So this is just an example of how the case looks like. So go look at the slide and see if you can make sense of that. Now, trig function, let's look at the standard function, which is the sine and the cos. You can see that it lies between 1 and minus 1, and we can draw it depending on what period that we actually want to use. For the sake of this course, please focus. Your angle is going to always be in radian and focus from 0 to 2 pi. So if I don't mention any interval, please just use 0 to 2 pi, all right? There's no way I'll be asking you a question and I expect you to use minus infinity to infinity when it comes to trig functions, all right? Now, the trick about these functions are they're periodic. For example, sine and cos, they have a period of 2 pi, means after 2 pi, they repeat themselves. So sine of x plus 2 pi is just equal to sine of x. Cos of x plus 2 pi is just equal to cos of x. And tan function is also a periodic function, but it has a period of pi. So tan of x plus pi will just give you tan of x. Now let's look at another kind of function called exponential function. I'm sure most of you are really shocked because you always thought that x to the power 2 is an exponential function. Lie. Exponential function is a number instead raised to the power x, not the other way, not x raised to a number. It's a number raised to the power x. That's exponential function. All right. And depending on the value of a, so we say that if a is greater than 0, you get an increasing curve. So for a greater than 1, for example, you get something that looks like this. And if a lies between, if a is strictly less than 1, so it lies between 0 and 1, you're going to get this kind of shape, all right? So just depending on the value of a, it will tell you if it's a growing curve or a decaying curve. You can see that 2 to the power x is this first one, is growing, increasing curve. 0.5 to the power x, you can see that your a is less than 1. It's a decaying curve, it's decreasing. All right. So watch out for stuff like this for MCQ. I ask you, what function best describes the graph? You should already see that it's increasing or it is decreasing curve. Logarithmic function. So all I need to mention for log function, what you see there, the a, you see there's a base. So you have log of x to some base a, and the domain is x strictly bigger than 0, all right? So there's no log of 0 or log of a negative number. So the domain of a log function is always x strictly bigger than 0. The range is from minus infinity to infinity, all right? And these are just examples of sketches for log function. All right, transcendental function. We say these are functions that are not algebraic. So every function that we've discussed so far, which is not algebraic in nature, we call those transcendental functions. All right. And I now give you this example. I say classify this. The first one is a number to the power x, obviously exponential function. Now x raised to some number, 5, you know it's a power function. Another student can say polynomial, that is very, very allowed. This one, you can see is a rational function and algebraic. So rational in the sense that you have a function of a function, but be careful, specifically I want you to say algebraic, all right? Because by definition, a rational function, you need a polynomial of a polynomial. If I ask you, is this guy at the bottom a polynomial? You can see it's not necessarily a polynomial because x is raised to the power half, all right? But for a polynomial, we want x raised to some integer power, all right? So the fact that this is raised to the power half and half is not an integer, just say algebraic. So this is algebraic, all right? So I'll mention again, this is exponential. This one is polynomial or power function. This guy is algebraic. And obviously this guy is very obvious, is polynomial of degree 4. You can see that the highest power of t there is 4. Polynomial of degree 4. And here they just explaining what I've mentioned already. Now let's do transformation of functions. You see stuff like this in your test or your assignment. Now transformation of function, I give you an original function and then I do something to that function. It gives me an entirely new function. For example, if I say y equals to f of x plus c, this is just a shift c units upwards. All right, so you're moving c units upwards, so along the y direction. Now, if I say y is f of x minus c, you can see the minus is in brackets. All right, so this is a shift c unit to the right. So this is now horizontal shift along the x direction, c units to the right. So take note, if it's negative, you go into the right, and if it's positive, you move into the left horizontally. And you can see there in this sketch here, you can see when it's minus, we move into the right. When it's plus, we shift into the left. If I add plus c, so I add the constant to my function, I'm going up. If I subtract the constant from my function, I'm going downward. And again, this is just a summary of what I've been explaining. More sketch to explain what is happening. Y equals to x squared is this first one. If I add 3, I'm moving in front. If I subtract 3, I'm going downward. All right. Now for horizontal shift, you see when it's negative, you get the blue one. It's this guy that you're moving to the right. When it's positive, you get the green guy. Is this one here? You're moving to the left. And take note, the transformation we've discussed so far is called rigid transformation. Rigid transformation because we're just simply shifting our graph, we're not changing the size of the graph. Now we're going to see something called non-rigid transformation. Non-rigid means the initial shape of the graph is going to change, all right? It's not just shifting it around, it's also making it bigger or smaller. For example, if I give you g of x is c times f of x, so I multiply my function with some constant c, all right? We say if c is greater than 1, it's a vertical stretch. So vertical stretch for c greater than 1, it means you're pulling it in the y direction, or it's getting taller in the y direction. And then you get vertical shrink when c lies between 0 and 1, all right? For c between 0 and 1, you get a shrinking. It means it's getting smaller and shorter in the y direction. Now, if I take the c inside the function, you see now the c is inside, all right? Now that is horizontal transformation. So it's a horizontal shrinking for c greater than 1 and horizontal stretching for c between 0 and 1. Please remember those. I might give you a function and say, explain the transformations to get my output function from a parent function, all right? For those of you that have downloaded the assignment, I'm sure you've seen stuff like this already. And that is just a summary of the non-rigid transformation. All right, so go look at this summary. And there you go, that's a sketch to show what's happening. Look at y equals to x squared. This guy that looks reddish. But see what happens with the blue one. You see we're changing the shape, all right? Look at this one. So you're changing the shape when you do non-rigid transformation. It's getting smaller or bigger. And that also applies for trig functions. You start with cos. If you half it, you're shrinking. If you multiply by 2, you're stressing. All right. Very important. Y equal to minus f of x means it's a reflection of your graph about the x-axis. All right. And y equals to f of minus x, so the minus is inside, is a reflection about the y-axis instead. All right. That's an example of transition. So you start with y equals the root of x, and now give you root of x minus 2. You see you move 2 units down from the origin, we move 2 units down. This is now 2 units to the right. Take note, this is 2 units to the right. Y equals to minus, remember we said this is a reflection about the x-axis. This will be a reflection about the y-axis. This will just be a vertical stretch, so you're stretching in the y direction. All right. And good news, there's more examples there for you to go practice. If I give you stuff like that and I ask you, explain the transformation, I'll explain this quickly. Start with what you see in brackets, all right? So start inside the bracket. You have 3 units, shift to the right, all right? So your parent function, first of all, tell me your parent function y equals to x squared. You're going to get a mark for that. and then tell me 3 units shift to the right, so that's horizontal shift to the right, and then you have 4 units shift upward. For sine function, what parent function is this? It's just y equals the sine of x, that's the parent function. I have a minus, which means a reflection about the x-axis, and then I need to move it 1 unit upward. Either you should be able to explain in words, or you should be able to sketch it. All right. All right, there are more examples there. You can see that I say identify the parent function, which is just absolute value of x, describe the sequence of transformation. There you see 2 unit shifts to the right. You see 3 unit shifts downward. So this is 3 unit shift downward, 2 unit shifts to the right. This is shrinking by a factor of 2. Sketch G just means sketch this, and then write G in terms of f. So if f is absolute value of x, then you should be able to just say f of x minus 2, and then you subtract 3, and then you say half of that. We're almost there. All right. Algebra of function. If I add two functions, so f plus g of x is the same as f of x plus g of x. F minus g of x is f of x minus g of x. F of g of x is just f of x times g of x. And take note of the domain is the intersection. All right. So when you add in, subtracting, multiplying, or dividing function, the domain is the intersection of both domains. All right. So A stands for the domain of the first function, B stands for the domain of the second function. Therefore, the domain of the sum of two functions, or the difference of two functions, or multiplying two functions or dividing two functions is just the intersection of the domain. Take note, for a case like this last one, you use the intersection of the domain, but you also include the fact that the bottom piece cannot be equal to 0. All right. So don't add an x value that is going to make the bottom piece 0, because that will be impossible. You can't divide by 0. All right. Now we're moving towards composition of function. I'll just jump straight to that. Let's see what it looks like. So function composition, if I say f of g of x, it simply means you go to the function f, everywhere you see x, you put the g function. So you take the function that is to your right, you put it into the function that is to your left. In this case, g is going into f, all right? When you see x in the f function, you need to replace it with the entire g function, all right? For example, in this way, I say find f of g and find g of f. F of g simply means I take x minus 3 and I put it in the place of x, so I have x minus 3 squared. G of f simply means instead take the f function and put it in g, so I'll get x squared minus 3. And this is just more example for you to do. F of g of h, again, you move in that order, you put h into g, you take the whole result, you put it into f. All right, the solution, like I said, is already on Blackboard. Go look at it. And here I'm just asking for domain, root of x and root of 2 minus x. Again, for root function, we say everything under the root has to be strictly greater than or equal to 0. All right. Be careful if the root function appears at the bottom. So if I give you a rational function and there's a root at the bottom, don't tell me that everything under the root is greater than or equal to 0. In that case, it's going to be strictly greater than 0. Because it's at the bottom, you can say equal to 0. All right. Any question from your side? We still have about 8 minutes. Anyone has something to ask? You can unmute your mic and ask your question if you have.